Imagine a factory floor. It's buzzing with activity. The air is filled with the sounds of productivity, and every corner is alive with motion. Machines hum, conveyor belts whir, and workers dart between stations, each performing their tasks with precision and speed. Now, imagine trying to improve this complex dance without stopping the music. Sounds impossible, right? How do you tweak a system that's always in motion? That's where industrial engineering and process simulation come in. These experts use advanced tools to model and test changes virtually. They're the secret weapons we use to optimize complex systems, from manufacturing plants to hospitals, without bringing everything to a grinding halt. They can foresee potential issues and solve them before they even occur. Intrigued? Buckle up, because we're about to dive deep into the world of virtual factories and simulated solutions. This is where the magic happens. But first, let's play a little game. A challenge to get your problem-solving gears turning. Imagine you're tasked with increasing the output of that factory by 20% without buying new equipment or hiring more workers. A daunting task, isn't it? Where do you even begin? What strategies would you employ? How would you identify the bottlenecks and streamline the processes? The answer, my friends, lies in the power of simulation. By creating a virtual model of the factory, you can test different scenarios and find the most efficient solution without disrupting the actual production. Industrial engineering is all about optimizing complex processes and systems. It's a field where precision and efficiency are paramount, and every detail counts. We're the efficiency experts, always on the lookout for bottlenecks, waste, and opportunities to improve. Our goal is to streamline operations, reduce costs, and enhance productivity. But how do we test our theories without disrupting real-world operations? This is where the challenge lies. Implementing changes in a live environment can be risky and costly. Enter process simulation, a powerful tool that allows us to create virtual replicas of real-world systems. With simulation, we can visualize and analyze processes in a controlled, risk-free environment. Using specialized software, we can model every step of a process, from the arrival of raw materials to the final product rolling off the assembly line. This comprehensive modeling helps us understand the intricacies of each phase. This digital twin allows us to run experiments, test different scenarios, and identify areas for improvement, all without touching a single piece of physical equipment. It's a game changer for innovation and efficiency. Need to see how a new layout affects production flow? Or perhaps you want to test the impact of a new machine? No problem, just tweak the virtual factory and hit run. The simulation will provide immediate feedback, allowing us to make informed decisions quickly. It's like having a time machine and a crystal ball all rolled into one. With simulation, we can predict outcomes, optimize processes, and stay ahead of the curve in the ever-evolving world of industrial engineering. Like any powerful tool, process simulation has its advantages and disadvantages. It's a double-edged sword that can either cut through inefficiencies or create new challenges. On the plus side, it's incredibly cost-effective. Companies can save significant amounts of money by testing changes in a virtual environment before making costly real-world adjustments. Testing changes in a virtual world is infinitely cheaper than implementing them in the real world and discovering they don't work. This can prevent expensive mistakes and reduce downtime. It also allows for rapid prototyping and experimentation. Engineers can quickly iterate on designs and processes, trying out new ideas without the fear of failure. Want to try out 10 different layouts before choosing the best one? Go for it. The flexibility of simulation software makes it easy to compare multiple scenarios and select the optimal solution. Simulation empowers you to be bold and innovative without the risk. It encourages creativity and out-of-the-box thinking, leading to groundbreaking advancements in industrial design. However, no simulation is perfect. There are inherent limitations and potential pitfalls that must be acknowledged. The accuracy of your results depends on the quality of your data and the fidelity of your model. If the input data is flawed, the simulation outcomes will be unreliable. Garbage in, garbage out, as they say. Ensuring high-quality data is crucial for meaningful and actionable insights. Moreover, building and validating complex simulations can be time-consuming and require specialized expertise. The process demands a significant investment of time and resources. But trust me, the insights gained from a well-crafted simulation are well worth the effort. The ability to foresee potential issues and optimize processes can lead to substantial improvements in efficiency and productivity.